Good morning, my dear friends. See now, Bubba, in the last class, we were seeing about the preliminary design of this PSCT section, and you know that we have reduced this section, and this is the final this thing now. Okay, 400 mm here, 900 mm here, 100 mm thickness, 100 mm thickness. Am I right? So we have given an area of 1,20,000. Am I right now? And since it is greater than required area AC, I say that it is okay. Now we shall go to now the final design by allowing no tension in concrete. Okay. So now for the above section, AC is equal to so much. Am I right now? We have provided 1,20,000 mm square area of concrete. Okay. So now, Baba, since it is a unsymmetrical section, I want to first of all find out the CGC, where CGC lies. Okay. So now what I should do, I have to take the moments of all these areas about the top. Okay. About the top, I go on taking the uh, uh, moments of these areas. Okay. So it is given by y bar is equal to sigma yg dA divided by sigma dA. Okay. So dA means first I will take this flange. 400 mm into 100 mm is the area. 400 mm into 100 mm is the area into its lever arm. Okay, its CG lies here. Its lever arm up to the top is 50 mm. Am I right now? It's 50. Plus, coming to this web, it is 800 into 100 is the area. 100 into 800 into its lever arm from the CG to this top is now 500 divided by sigma dA. Sigma dA means it is the summation of the areas. Okay. So now it will give you 400 mm from the top. In the sense, your CGC lies at 400 mm from the top. In the sense, your YT is 400 and the remaining YB you can easily calculate because this total is 900. Okay. So YT is 400. So this YB should be now 500 mm. Am I right now? So I can mark YT and YB also now. Okay. So now, also for this cross section, I think you can easily calculate your IGXX also. Okay. So now, without wasting the time, IGXX value is 9.99 into 10 to the power of 9 mm fourth. Okay. So now, also I can easily calculate this R square. R square is I by AC. I know. Just now we have calculated. AC also I know. It is 1,20,000. Okay. So now we will get so much. So now once I know R square, I think I can easily calculate my KB value and KT value. KB is given by R square by YT. Am I right? So R square I know. Okay. YT also I know. YT value is now 400 mm. Am I right? Okay. So your KB value is so much. Similarly, KT value is R square by YB. Okay. R square I know. YB also I know. Okay. So it is so much. So now KT and KB also can be now easily calculated in this final design. Okay. So now, Baba, you have already calculated the effective pre-stress approximately as PE is equal to so much. So now I want to convert it into initial pre-stress, PI. It is FPI by FPE into PE. In the sense it is loss of pre-stress, as you know, this eta. Okay. So now FPI I know, FPE you know. Okay. These values are given to you in the problem. PE I know. So it will give me initial pre-stress as so much. So always initial pre-stress will be always greater than the final pre-stress. You can see here. Okay, initial pre-stress is 9230. Okay, here it is 76. Okay, so now, Papa, now we'll try to calculate the eccentricity. Okay, eccentricity can be calculated by one equation: E minus KB is equal to MD by PI. Am I right now? So now MD I know. Okay, and PI just now we have calculated. Okay, so now it will give me E minus KB is equal to so much. So now eccentricity can be now easily calculated. This plus KB. Okay, E is equal to this plus KB will give me eccentricity, an eccentricity of 567 566 mm is required now. In the sense, according to our calculation, I need an eccentricity of 566 mm. Am I right? So now, but now the problem is, see now, this figure, just see, your YB value is how much now? 500 mm. Am I right now? This is your CGC. Am I right now? This YB value is 500 mm. But how much is your eccentricity now? It is 566. Okay, Baba, 566 eccentricity you cannot accommodate here because YB is 500 mm. If I want to come 566 mm, it will take me beyond the cross section. Am I right now? 566 mm becomes beyond the cross section. So, but now the problem is here now. Okay, I cannot provide an eccentricity of 566 mm. So now what I should do is, now I have to provide an eccentricity of available eccentricity. I have to give, okay, then I should proceed. So what I am going to do is now, okay, see now. So now, but eccentricity of 566 mm is not available. Okay, so now what I will do is now, I will provide an eccentricity of 420 mm. Okay, I will provide a cover of say 80 mm. So if I give a cover of 80 mm, so I will be left with 500 minus 80, 420 mm. Okay, so now I am going to provide an eccentricity of 420 mm. In the sense, I am going to now provide the steel somewhere here now. Okay, provide the steel here somewhere here. The eccentricity from here to here is now say 480 mm. Sorry, 420 mm. Am I right now? 80 mm is my cover. Okay, so 420 mm is my eccentricity. Okay, so now when I change the eccentricity, Baba, there is a problem. Okay, when I change the eccentricity, okay, now I have to calculate my effective pre-stress required now. It is now new effective pre-stress. Okay, it is given by MT divided by E plus KT. So MT I know. Eccentricity is now new eccentricity 420 mm. KT value I know. Baba, this is my new effective pre-stress required PE. Baba, once I know PE, I can easily calculate PI also. It is the initial pre-stress required. It is FPI by FP into PE. So all the values are known to you. So I can easily calculate the initial pre-stress also now. It is so much. Okay. So now, also now, AC required at working condition. Baba, this I can easily calculate. AC required in the working condition is given by AC is equal to PE D divided by FCCF into YB. Baba, all the values are known to you. PE is, it is a revised PE. It's here 852283, 852283. Effect overall depth I know. Okay, FCCF you know, and YB you know. Okay, so you will get AC required in working condition is 118008. Baba, this is the required AC. But how much we have given now? AC 1,20,000. I need 1,18,000, but provided AC is 1,20,000. So now I say that I have given more area than the required. Therefore, I say that your cross-sectional area provided for T section is okay in working condition. Okay. So similarly, I want to calculate AC required at a transfer or AC required in the initial condition. Baba, in initial condition, AC required is given by AC is equal to PI by FCCI into E minus MD by PI into divided by KT. Baba, fill all the values. You will get a value of 108016 mm square. Baba, again, you will see that this area, I need it. I have given an area of 1,20,000. In the sense, I need 1,08,000 area, but I have given 1,20,000. I have given slightly more area than the required. So now I say that now my in sense now cross section provided for the T section is also safe in initial condition. Okay, that is how Baba now final design can be now done. Baba, now allowing and considering the tension, it is not there in your syllabus, so we need not see it. Okay, that is how Baba now the design can be now done. Okay, thank you very much.